looked at Newton's first law and Newton's law of universal gravitation, and we've done a lab that starts to introduce us to Newton's second law. So today we're going to look and see what exactly Newton's second law is. So, Newton's second law says that a net force acting on an object causes the object to accelerate in the direction of the net force. So if I am applying a force to the right, my object is going to accelerate to the right. If I apply a force to the left, my object is going to accelerate to the left. The greater the mass, the greater the force is needed to accelerate it at the same rate as another smaller object. So if I'm talking about accelerating my Impala versus my husband's Silverado, it's going to take a lot more force to cause the same acceleration in his Silverado than it is my Impala. It also says that the greater the net force, the greater acceleration. So if I were to apply 10 newtons of force to my car, or 40 newtons of force to my car, the 40 newtons of force to my car is going to cause a lot more acceleration than the 10 newtons. Now, the equation for Newton's second law is F equals ma, where F is the force measured in newtons, m is the mass measured in kilograms, and that's important. You need to make sure that you're measuring your mass in kilograms and not in grams or something else. And a is the acceleration measured in meters per second squared. So, if you push a friend on a sled and you push with a force of 30 newtons, your friend and the sled together have a mass of 65 kilograms. If we ignore friction, I want to know what is the acceleration of your friend. So, I'm not going to be able to write this out for you like I normally would, but we choose our equation. F equals ma. Where F is, we plug in 30, and where m is, we plug in 65. So to solve this for a, I have to divide both sides by 65. So then I have 30 divided by 65 equals a. When I plug that into my calculator, I find that a is 0.462 meters per second squared. Weight is also a force. So weight also takes advantage of Newton's second law's equation. So weight is actually the force of gravity on an object. Because it's a force, we can calculate it using F equals ma. The acceleration is always the acceleration due to gravity. So the a is always the same number as long as we're talking about the weight of something on Earth. If I move it to the moon or to Mars, acceleration due to gravity changes, and that number would be given to you in a problem. But on Earth, a is always 9.8 meters per second squared if you're solving for the weight of something. So if I want to find the weight of a suitcase that has a mass of 38 kilograms, my weight is actually my F. So F is my question mark here. And M is 38 kilograms. It says that the mass of the suitcase is 38 kilograms. Now, it doesn't say that it's on Earth, but I can make the assumption that it's on Earth because it doesn't say otherwise. So A is 9.8. So if I take 38 times 9.8, I get 372.4 newtons as my force, which is also the weight of the suitcase.